This demonstration shows how the FAST scheduling system handles not only the simplest scheduling problems, but also how it captures problems with increasing complexity. By starting simple, we can show the basic operations of the system, and by doing that, provide a guide for getting started. But if you're looking for a scheduling system for a very challenging environment, stay with us, because as the demo progresses, we'll show you a lot of capability that will apply to virtually any environment, no matter how complex it is. When you become a user, we create for you what is called a site. In this demo, the site is called Acme Manufacturing. Within your site, you can create several different domains, and within each domain, you can create any number of timelines. For this demo, assume you're a company with several offices, and we've created a domain called Springfield Office and a timeline called Meeting Schedule. Let's start with a very simple resource booking problem. We'll schedule a meeting into a conference room. We've made the conference room available for March 16th from 8 to 5. We'll define one activity called Project Kickoff Meeting with a duration of 2 hours and a requirement for the conference room. Once the activity is defined, we can schedule it immediately by clicking the Schedule button. Notice that the activity now appears on the scheduled list, and the conference room is now booked. Let's suppose we didn't want to schedule the meeting to start at 8 a.m. Instead, we wanted it to start at 9:30. Let's unschedule a meeting and go back to the activity editor and look at the possibilities. This shows we could schedule this activity starting any time between 8 a.m. and 3 p.m. as expected. To schedule at 9:30, we simply specify that start time. So that's all there is to it for using the FAST system as a single resource booking system. Next, we'll look at scheduling more than one activity at a time. We've created a second activity called Senior Staff Meeting with a duration of 93 minutes and a requirement for the conference room. And we realize that meetings are usually not scheduled down to the odd minute, but we did this to illustrate that the FAST system does not assume any preset intervals for durations or any other time references. To schedule multiple activities, you simply select the ones that you want to schedule and hit the Schedule button. Now let's postulate that the senior staff meeting also requires a laptop computer. We've added 2 laptops called Laptop A and Laptop B, available between 8 and 5. We've also specified that the senior staff meeting activity requires a laptop, but here we've said that any laptop will do. That's what we call a wildcard resource requirement. Unlike other systems, the FAST system will find all combinations of wildcard resources and select the combination that best contributes to the scheduling objective. Let's reschedule both activities. The system selected Laptop B. Now to add a little generality, let's assume that the laptop is not really needed for the first 45 minutes of the meeting. We can simply change the requirement to show that offset. Let's look at the resource usage profile now. Most scheduling systems assume that all resources are used for the entire duration of the activity. The FAST system does not have this limitation. You can specify as many on and off intervals within the activity as you wish. Let's create a slightly bigger scheduling situation. We've added another resource called Boardroom and an activity called Proposal Preparation with a duration of 5 hours and 10 minutes, and another activity called Project 42 Monthly Status with a duration of 75 minutes. We'll use wildcard requirements for the rooms on all of these activities. You can see the possibilities for scheduling by going to the Activity Editor and opening the Possibilities button. This is a unique feature of the FAST Scheduler. It shows all possible combinations of resources and start times when the activity can be scheduled. The user can pick any one of these possibilities and schedule the activity manually, or let the system pick the best possibility. There are multiple solvers available in the FAST system. The default one is called Tightly Packed, which tries to use the resources as efficiently as possible. The other is called the Fair Share Solver. It tends to utilize as many resources as possible, distributing the assignments as equally as possible. To show the difference, let's unschedule everything and reschedule with the Fair Share Solver. Say that there are people who must be in these meetings, and some of them have to be in more than one meeting. We've added Joe Jones, who is the VP of Operations, and we assume that he needs to be part of the senior staff meeting and the proposal preparation meeting, but he isn't needed for the entire duration of either meeting. Let's assume he's needed for the first 10 minutes and the last 15 minutes of the proposal preparation meeting, and is needed for the first hour of the senior staff meeting. Let's reschedule and show the assignments for Mr. Jones. Mr. Jones is in the proposal preparation meeting from 9:15 to 9:25. He goes to the senior staff meeting between 10 and 11, and he's back in the proposal preparation meeting from 2:10 to 2:25. Let's look at how we handle pooled resources. These are resources that are available in quantities greater than one. Let's assume that all these meetings require chairs. And let's assume that there are 20 chairs available. This initial availability can also be a function of time. But to keep things simple, we'll just assume a constant initial pool of chairs is available. We'll add requirements for chairs for each of the meetings. So now let's reschedule with all the chair requirements added. Notice that the constraint on chairs did not allow one of the activities to be scheduled. We know that chairs shouldn't constrain the schedule because we can probably find more. Let's see how many chairs we are actually going to need. To do this, we'll use another unique feature of the FAST system. We'll switch the requirement for chairs in the proposal preparation meeting from being strictly enforced to being tracked. The system will now allow the violation of the constraint, but it will show us exactly how big the violation was and when it occurred. So let's reschedule with this change. Note that all activities scheduled as expected. So let's see how many chairs we actually needed. Notice the overuse in the profile. and the graphic shows that we actually needed 31 chairs, and we have 20. The track feature is a key to using the FAST system for capacity planning. If you anticipate that you might need additional resources, by using the track mode, you can see immediately what resources are needed, when they are needed, and in what quantities they're needed. Assume one additional constraint. Let's assume that the senior staff meeting must be concluded before the Project 42 monthly status meeting starts. Let's even say that it must be over 20 minutes before the status meeting starts. We'll specify the predecessor and offset relationships between the two activities by adding the predecessor and offset to the Project 42 monthly status activity. So let's go back and reschedule everything again. Note that the senior staff meeting ended at 9:33 and the Project 42 project status started at 9:53, exactly 20 minutes after the other one concluded. You can have as many predecessor relationships as you want. You can specify an entire precedence network as you see in project scheduling. This demonstration has illustrated several important points. First, that the simplest problems are also simple using FAST. Second, that as the complexity of your scheduling environment increases, the capabilities of the FAST system can accommodate your needs. And third, that whether your domain is manufacturing, healthcare, services, hospitality, transportation, education, sports, or any other domain, the FAST scheduler is a good fit.